Zoax.net. Lesson 10. Heapsort. We covered heaps in the prior algorithms lesson, and now we are going to show how to use a heap to sort an array of entries. Once you understand heaps, the heap sort is very straightforward. The heap sort consists of two steps. For the first step, we construct a heap with all the elements in the array. For clarification, we color-code the levels of the heap with 4 shades of gray so that we can see the implicit tree structure. 81 is the parent of 67 and 78, and 67 is the parent of 62 and 64, for example. For the second step, we use the heap to sort the array. These two steps are almost identical to what we did in our lesson on heaps. In fact, we will see that we only need to change one line of our previous heap program to make the heap sort. The heap creation step consists of adding each successive element to the heap, just as we did in our heap lesson. Here we show the elements in the heap with the graded gray background and the elements that have not been added to the heap in red. We continue adding elements until all of them are in the heap. For clarity, we will show the procedure for adding a single element to the heap. After we have added the first 9 elements, we add 64 to the end of the heap. However, this new element is not in the correct location to make a heap. We check whether the element 64 needs to be moved by comparing it with its parent, which is 41. Since 64 is larger than 41, we swap the elements. Next, we compare 64 to its new parent, which is 67. Since 67 is larger than 64, we are done, and we have a new, larger heap. Once we finish making the heap, we can use the heap to sort the elements by moving the largest element, which is always at the root. We repeatedly take the root element and put it in the next position at the end of the heap. We change the background to green for the sorted elements. To move the root element, we swap it with the last element of the heap, and then swap the new root down the tree with its larger child until it reaches its proper place. To illustrate, we now give an example of how that works. Let's go back to the point where the first 6 elements of the array are in the heap and the rest are sorted. In this case, we swap the root, which is 41, with the last element, which is 0. At this point, we have the shortened heap, but we still need to put the root element 0 in its proper place. 0 has 2 children, 27 and 34. Since 0 is smaller than the larger of its children, we swap it with its larger child, which is 34. After swapping 0 and 34, 0 becomes a leaf node in our heap, so we are done. That's the entire heap sort algorithm. The C++ code is up on our lesson page at Zoax.net. The code is very similar to our prior heaps lesson code. We only changed one line of the algorithm. We replaced the assignment at the beginning of remove root with a call to swap that swaps the first and last elements. That is all we need to make our prior program sort the array. However, I also changed the display code so that we will be better able to see the sort in action. First, I removed the output heap function and the calls to that function from main because we already saw the tree structure and we want to focus on the sorting algorithm. Then I changed the output array function to take an extra parameter that specifies a position where we want to print a vertical bar. In our main function, I added the array size, which is 15, as the third parameter of output array. So if we compile and execute the program, we see arrays printed that mark the stages of the algorithm we already described. The arrays are printed with a vertical bar to separate the parts of the array. In the first half of the output, the vertical bar divides the entries that are in the heap from the entries that have not yet been touched. In the last half, the vertical bar divides the entries which form the heap from the entries that are sorted.